We're going on now to topic 7, the last section of chapter 8, and it feeds from 8.6. So if you have time, I would strongly advise you to watch the PowerPoint of 8.6. So more about graphing of quadratic functions. Here we're going to feature finding the vertex and finding intercepts. Now, before we go on, I want to review the formula, which is the vertex formula, and that would be in function form here. F of x is this. Now, this was derived from the standard form, and I'm going to show you how to do that. But you may recall that we said if A was positive, the parabola would be opening toward the top. And then we said if A was negative, the parabola is opening toward the bottom. And then we mentioned the word already, vertex. The vertex of a parabola, if A is positive, the vertex is given by the coordinates h, k in this formula, and that would be an x value for the h, a y value for the k, and if A is positive once again, it opens toward the top, and the vertex is right there. It's the lowest point of the parabola, so that would be called the minimum. Okay? If A is positive, the vertex is the minimum. Now, if A is negative, the vertex is going to be the maximum because it's opening down and the curve is at the top here. So if A is negative, the vertex here is the maximum. If A is positive, the vertex is the minimum. And then we have what is called the axis of symmetry. And the axis of symmetry is actually our h value or our y value. And here it would be right there. And over here it would be right there. I'm off a little bit, but you get to see the idea of it. Now, there's one other thing I want to point out before we leave this slide, and that is our intercepts. Now, for this parabola, where will this parabola cross the x-axis? Right there and right there. So these are the x-intercepts, a comma 0. And there's two of them. And this relates to finding the zeros. Okay? We'll get to that toward the end. And over here, the x-intercepts are right there and right there. Notice when we find our x-intercepts, our y value is 0. Now, when we want to find the y-intercept, the y-intercept is over here and over there. That's where the parabola will cross the y-axis. And what is the value of, and I guess you can't see that too well, but what is the value of y here? Well, we don't know that. That's going to be b, we said. What's the value of x? Well, that's the one that's 0. So for the y-intercept, it's going to be 0, comma b. X is 0. Okay? And we'll go over that. But this is all review from previous lessons. Okay. I think I went by this one too fast. Now, we're going to use the concept of completing the square to convert this form, which is standard form, into the vertex form. And there is a little recipe that I will show you. Okay, let's go on. Now here's the recipe. And I have these two formula, the standard form and the vertex form, as reference. So there's this equation. I'm just going to use the right side. And I've just copied it down. But I've taken the c term, which is a -1, and moved that out. Because what I want to do here is I want to make this part of our beginning of a trinomial into a perfect square trinomial that I will factor into a binomial square. So we did that in section 8.1. We said to do that, we bring this x down here, we bring this sign down, and we take half of our b term, which will be 1. Then we will square this, put that here. And here's the sort of the recipe part. Since we added 1 here to this, in order to keep it the same, I have to subtract 1 over here. So if I add 1 and subtract 1, then I just have this again. But I'm putting it in a form. So now I'm factoring this into its binomial square, adding that up, and I get a -2. And lo and behold, I've converted it from this form to this form. Now, from this form, we can pick out a couple of things. So for instance, would this parabola, and keep in mind a out here is just a 1, would this parabola open upward or downward? Upward. A is positive. Okay, what will be our vertex? Now we said it's going to be, by the way, the vertex is h, comma, k. And we had said before that when it's in this form, what is h? Well, h is a positive 1. We said if you looked at it this way, it's opposite sign. But h is a positive 1 because you'd put a positive 1 right there, and that would make that a negative h. So h is a positive 1. And our y, our k value, is just -2. Now, what is our h value? Well, this we said was the axis of symmetry, and this k is our, in this case, minimum. And this is the vertex, okay? So from just those little bits of things, we were able to pick out lots of stuff. Let's go on. So here they've worked it all out for us step by step. They move this over. You're adding one, subtracting one. Move that outside the parenthesis. There's where we get our -2. And our vertex is opposite sign, positive one, and this is our y. Okay. And if you graph it, there is our vertex. Now what's our axis of symmetry? Well, we said it was a 1. So it'd be a line, dotted line right down through x is 1. Okay? And again, it opens upward. All right, this one's again a little more tricky, and I have done this before. So let's do it here. So we're going to go -2x squared plus 6x, and I move my c term out there. Now I'm going to factor out here a -2, and then I get an x squared minus 3x. Now what I'm going to do is take, because I want to factor that, I'm going to take half of a -3, and if I take half of a -3 times 1/2, I get a, well, let's put the x there first, the minus there, and half of that is going to be a -3/2. There we go. Now, what I'm going to do is square this, and that's going to give me a positive 9/4. Now my -3 is still out there, but if I'm adding 9/4 here, I have to subtract 9/4 there. Okay, so I factored this, and this is the first part of my vertex formula. And now I'm going to put in my k, and in order to add this 3 to it, let's get my common denominator here. Common denominator is going to be 4, so this is 9. Now, this is over 1, so in order to get this is going to become 12/4. So this is -12 over 4. So when I add that together, I get a -21/4. So this was kind of a tricky one. So once again, this is now in the form of the vertex formula. My a is a -2, and I think I left something out here. Yes, I did. So I have to go back because I forgot to multiply this by a -2 here. There we go. So I have to take a step back here. Yeah, I got a little distracted here. So yes, when I pulled out that -2 and I added my square of this, 9/4, I had to have the -2 there as well to keep that proportional. There you go. So now what happens here? Well, 4 will go into there, 2 go in there once, this goes twice. So I end up here with a positive now, 9/2. That's better. So now I have to add these two together. So my common denominator is going to be 2. This is 9/2 minus, I'm going to multiply that by 2. This becomes 6. And this becomes then 3/2. So let's write this all out. So -2x minus 3/2 the quantity squared plus 3/2. Okay, so again, it's A is negative, so it's going to open downward, and my vertex will be opposite signs, so 3/2, and my uh, minimum, or in this case, it's going to be a maximum. My K value is 3/2 also. Okay, and this is my axis of symmetry. You can think of that as 1.5, and this one also. All right, well, let's see how we did, because they have this worked out for you too. Yes, okay. In fact, I should have probably looked at this first and realized I had to bring my 2 over there too. Okay. And again, it opens up toward the bottom. Remember, as we increase our values of A, they get the lines of the parabola get closer together. If we had a 1/4 there, negative 1/4, these would be quite broad. And the regular 1 was a little bit more broad than this. Okay. So they're showing you here some coordinates, but I'm not going to use this particularly here. Oh yes, we want to find our intercepts. So we can look for this. Here, you read it to yourselves as I read it here a little bit. For any function, the y-intercept occurs at, again, we're finding the zeros when x is 0. And the y-intercept we find when y equals 0. Okay, I'm going to go over this with you right now. So if we had an equation like this, what can you say about the a here? Well, the a would have been negative, and if f of x, this was our y value, was a 0, as we have right here, these would be where our x-intercepts would be. And if x were 0 right there, we put a 0 there and a 0 there, our c value would be right about there. Now, I don't know if they're going to show us an example here or not. Yes, good. Okay, I looked at this a little bit here. So let's get this set up. And for this, I strongly suggest that you make a T-chart. Now for our Okay, I left that running, and that's okay. What we did is we were setting this up. These will be our x-intercepts, and we'll usually have 2, and this is going to be our y-intercept. We usually have 1. So when here we are looking for when y is a 0. And we want to find our values here. Well, we can use completing the square for this. Okay, so I could have used the quadratic formula, but I used completing the square here. I took my -1, brought it over as a +1. I set up my binomial, took my x plus half of 3, squared this, got that, added that to both sides. I had to add these together, so my 1 became 4/4. This gave me 13/4. Took the square root of both sides, transposed my +3/2, and when I took the square root of that, I got the square root of 13/2, since 4 is a perfect square. So here are my 2 points. One will be a -3/2 plus the square root of 13/2, and the other one is a -3/2 minus the square root of 13/2. So these are my x-intercepts. This was like finding the zeros of this. And now if my x is 0, I can go right into this formula here. If x is 0, this is a 0, this is a 0, y is going to equal a -1. And that will be my x-intercept. Okay? And again, they didn't ask us to find the vertex or anything here, so they just wanted us to find the intercepts. And there they are. And they're showing us plus or minus. Okay, that's one way to show it. And that wraps us up. Well, good luck with your test. Again, I have on the whiteboard a pretty good lesson of this as well, that if you have time, I would strongly suggest you watch it, as well as some of the additional exercises. And good luck.